Welcome back to the morning show. We have our fingers on the pulse of science this morning and our fists tightly wrapped around these things.
Quite literally. And this morning, the wise guy and Dr. Z are going to team up and show us how an EKG works. We're going to check in with Dr. Z in our next segment. But right now, we're going to have Matt explain to us what exactly we're seeing on this monitor and how this EKG actually works scientifically.
So what I built here was a sort of a cheap knockoff copy of an EKG machine. So it only has a pair of things that you're holding on to, and if you'd hold on to those things again,
both of them, huh?
Right, so basically, the little machine, I'll explain that to you in a second. It's just an amplifier that sits over here in that little black box, and the output of it goes into this oscilloscope, and this is the sort of thing that you see on ER when you go beep, 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 and then beep. Right. So hopefully we won't see that happen. But so what's happening on this trace is there's a yellow dot that's being drawn across the screen as a function of time, and it kind of moves across slowly, and whenever there's a change in the voltage that comes out of this EKG machine, which is a result of your heart beating, let's say, the thing goes up for a positive voltage or down for a negative voltage, and so the net result is you get a little line that's drawn across the screen, and it wiggles up and down, and it shows you what the voltage is as a function of time.
Now, where did this, I guess it's developed over the past couple hundred years. I think we have a picture of what we used to use, what was used, I think, back in the 1880s. That's scary.
Oh.
They used to use that. That was the predecessor to this, yeah?
Right, I guess so. I mean, so I haven't seen one of those, but this looks even clunkier than that.
No, it doesn't.
But let me tell you what the challenge is in this. The signal that comes from your heart is very, very small. Yeah. It's a tiny fraction of a millivolt, so millionths of volts. I mean, it's very tiny. So what you need is an amplifier which has a gain that's pretty large. So the thing I built here has a gain of about 500, and the little chip that you might see if you look into this box is just something that you can get at Radio Shack for $1 or $2, so you can build this at home. And what that means is, though, when you're looking at signals that are that tiny, just about anything can interfere with it. So the signals from the lights and everything else in this room. So
even something that faint, just
yes, exactly. So if you just take those and put them down on the table, when you're not touching them anymore, what you're going to see is that the screen just goes crazy here. And so it's all yellow now, and the reason for that is that just from these things laying on the table, you get such a much bigger signal than you would from your heart. And so that's the challenge when you build these machines, is to sort of isolate the person and the machinery from just pickup and lights and everything else that's around in the room.
Right. It seems to me, I've had one, and it seems to me the room is kind of dark, or not
dark. They want you to lay very, very still,
right? Because
also just breathing and moving around and your other muscles firing will cause this thing to go crazy.
So we can run around the room.
Right.
Well, usually, aren't the other machines much bigger than this?
Well, yeah, and they stick
and they cost more too.
Yeah,
okay.
That's
well, and we will take a look at how they work more.
How they work, and Dr. Z will kind of tell us what we're looking at.
Right. So we'll come back. Right. We'll come back, and then Dr. Z will explain to us everything that we're seeing.
No signal.
Right.
Stay with us. We'll be right back.
Right.
They